part B. It says, show that alpha equals 4 arc sine 1 on 4. Now, I saw this, I used a pretty similar technique to method 1 in the marks game, if you do have that. Now, how we did that is, let's picture my D here. This should be there. Okay, so if I look at the triangle, if I create a triangle here, now B is the center of this circle, D is the outside. So if I put a line connecting them, and then I draw a triangle here, this angle will be a half of the angle that we had. So if I then split this up into a half again, and I give this a coordinate, let's just give this M, the midpoint of D and B. So this is a straight line. Okay. Inside here will be alpha on 4. So if I picture this as a right angle triangle, which it is, I'm going to have sine of alpha on 4 will equal opposite. Now the opposite, which will be, this is a half of dB. Now dB is just the radius of this smaller circle. So this is a half of R, and the sine is opposite over hypotenuse. The hypotenuse is 2R. So I'm going to get sine of alpha on 4. Now a half, the R's will cancel out. A half over 2 is just a quarter. So from there, I can say that alpha on 4 will equal arc sine of 1 on 4. And then if I times the 4 up, I get alpha equals 4 arc sine 1 on 4, which was what the question asked us to find. So the key to this question here is that it said arc sine of 1 on 4, so, and it had alpha potentially on 4, so I knew I needed to split this alpha up into quarters, and the way I could do that was in a half, and then half again. This was alpha on 4, and I created a right angle triangle here, which I did know the opposite and the hypotenuse, and they were in terms of R, and they ended up cancelling out. So that's the answer to part B.